you ever wondered where Oumuamua is actually going after traveling for 45 million years? This space rock is always moving through space, so figuring out its final destination is a real challenge. Much of the world is curious about NASA's new discovery of the first interstellar object in space. Scientists around the world keep scratching their heads, trying to piece together clues about where it came from and where it might end up. Is Oumuamua an alien artifact, a giant cosmic dust cigar, or something entirely different? And will it ever stop moving? We're uncovering 9 theories developed by world-renowned astronomers that try to answer all these questions. It's been 7 years since the Pan-STARRS 1 telescope in Hawaii first caught a glimpse of Oumuamua. And ever since that big day, scientists have been trying to pin down exactly where this interstellar object is heading. And in order to track its path, the first thing we need to get a handle on is its speed, because its speed plays a huge part in shaping its trajectory and how it behaves within our solar system. High speeds mean high kinetic energy, which really changes how objects move and interact in space. Oumuamua zipped through our neighborhood at a jaw-dropping speed of about 315,000 kilometers per hour, or 196,000 miles per hour relative to the sun. With such a high speed, it isn't held back by the sun's gravitational pull. This matters because the faster an object is moving, the less time it has to hang around near big stuff like planets. For this interstellar, this meant it just made a quick flyby without sticking around for any major gravitational pull to mess with its path. And its destination isn't just about how fast it travels. Its shape and size also give us clues about where it's headed. It's kind of like a giant space cigar, stretching somewhere between 100 and 1,000 meters in length, while its width and thickness might be around 35 to 167 meters. The bigger and faster something is, the more kinetic energy it carries, which is a big deal if it were to crash into another space object. If we imagine this space rock being slammed into a planet or moon, this collision would unleash a massive amount of energy, possibly causing some serious cosmic havoc. So understanding its speed, shape, and size helps us get why tracking its path is so important. It's not just about where it's going, but also about the potential interstellar drama it could cause along the way. Astronomers determined that it entered our solar system from the direction of Vega, a prominent star in the Lyra constellation. However, calculations show that Vega was not in this position when this cosmic visitor would have passed by approximately 300,000 years ago. This indicates that it has been traveling through the Milky Way independently of any home star, drifting through space and coincidentally crossing paths with our solar system. So you might be wondering, if this asteroid-like thing is just cruising through the Milky Way without a real home or a specific destination, where exactly is it headed? What's its path through the stars? Well, we've dug up some juicy details from the not-so-secret anymore chambers of NASA. Now let's get one thing straight. This deep space object is not just wandering around the cosmos aimlessly. Although it might seem to be moving randomly, a closer look at its history of trajectory tells us there's a specific pattern here that's been decoded by the sharp minds at NASA. When it entered our solar system in October 2017, it made a big splash like a surprise guest star in a movie. It quickly zoomed in towards the sun, whipped around it, and then sped off, all by January 2018. Its path was a sharp curve that showed it wasn't going to stick around because it wasn't tied down by the sun's gravity. As this space traveler continues its silent journey across the cosmos, perhaps one day it will find its place among the stars, a quiet home in the vast universe. Normally, objects speed up because of the sun's gravity when they get closer, but it was already moving even faster than that. It acted like a comet that speeds up by shooting out gas, which works like a little rocket booster. However, it lacked a visible tail or coma, typical features of outgassing comets. So the big question was, what was really pushing it along? Figuring out this mystery will help us understand where it is headed as it travels through space. As it swung past the sun and started heading back into deep space, this mysterious acceleration continued. The data suggested that instead of just being hurled away by the sun's gravity, it was actually picking up a bit of extra speed. This non-gravitational motion hinted that it might share some properties with comets, but without the usual comet-like features, such as a tail. Now, predicting where this space enigma is heading next is like trying to forecast the exact path of a thrown baseball before it lands. Based on its speed and trajectory, we know it's en route to the constellation Pegasus. and will zip past Neptune's orbit in a few years. Swift pace ensures that this alien entity won't be gravitationally captured by any star system soon. This interstellar journey could bring it close to other stars, possibly altering its course again through gravitational interactions. But the majority of scientists still say that the trajectory of this space rock is in doubt, and there can be so many possible interpretations for it. To give a more profound answer to where the alien entity is going, they've laid out several theories. Each theory not only offers a possible explanation for its peculiar motion, but also enhances our broader understanding of how objects from other star systems might interact with our own. The cometary outgassing theory was initially considered by astronomers to explain its behavior. Comets emit gas when they near the sun, which can act like a thruster, altering their paths. This could explain the unexpected speed of this extraterrestrial object that increased as it swung around the sun. However, this space rock didn't have the tail that comets usually have when they do this. If it was outgassing, it did so without these visual cues, suggesting a unique composition or behavior. Understanding this helps us predict its current path, indicating it continues to travel away from the sun, influenced by forces beyond simple gravitational pulls. Another hypothesis is the solar radiation pressure theory. This suggests that this galactic traveler might be unusually light-weighted, possibly made of porous or fractal material, making it susceptible to the slight but constant push of sunlight. This theory accounts for the observed speed and trajectory changes without typical cometary behavior, offering a plausible explanation for its non-gravitational acceleration. Knowing this, we can better chart its future path as it exits our solar system, driven by the continuous influence of solar radiation pressure. The hydrogen iceberg hypothesis delves into speculative territory, suggesting that this interstellar probe might be a solid chunk of hydrogen. Researchers like Seligman and Laughlin proposed that as it neared the sun, the solid hydrogen would sublimate into gas, accelerating it similarly to outgassing but without visible effects. Since hydrogen gas is invisible in space, this model explains the acceleration observed in the path of this celestial body and helps us understand its current and future trajectory. As it continues its journey, the lack of visible outgassing confirms that it is propelled by forces beyond standard cometary behavior, offering clues about its ongoing direction. Lastly, the tidal fragmentation theory presents a dramatic origin story for impacting its trajectory. This theory suggests this interstellar object might be a fragment from a larger object torn apart during a close encounter with a star or another significant gravitational force before entering our solar system. This violent event could explain its elongated, tumbling shape and erratic course. Understanding this origin helps us predict where it is headed, as the remnants of such an encounter are likely to follow unpredictable paths, influenced by their irregular shapes and spins. Then there are other strange theories about its trajectory. One headline-making theory comes from Harvard's Avi Loeb, who proposed that this extraterrestrial object might be an alien technology artifact, like a light sail from an advanced alien civilization. Picture a thin, flat sheet cruising through space, pushed by sunlight. This isn't just sci-fi. It mirrors projects like the Breakthrough Starshot Initiative, where humans are experimenting with sending light sailcrafts to other stars. According to Loeb, this theory could explain the specific path of this alien asteroid, suggesting it has a destination rather than aimlessly tumbling through space. The interstellar dust aggregation theory suggests it could be a cosmic dust bunny, a clump of space dust held together by weak van der Waals forces. This delicate structure could be more sensitive to solar radiation, getting a slight push each time it spins by the sun. This theory not only explains its acceleration, but also helps us understand its future trajectory as it moves through space, influenced by solar radiation. Pushing the boundaries further, some speculate about non-sail artificial origins. This theory imagines every interstellar as an extraterrestrial probe or a piece of alien tech sent to explore the galaxy. Unlike the light sail concept, this idea opens the door to various alien gadgets, perhaps a cosmic scout silently gathering data. While this space phenomenon hasn't been detected sending signals, this theory still shapes our understanding of its path, suggesting it might be on a purposeful journey. If you think the trajectory hunt stops with those strange theories, it doesn't, because there's another set of ideas that steer clear of any alien tech or cosmic dust theories. These are called the unconventional natural theories, which dive into phenomena that aren't well understood or directly observed, like dark matter and cryovolcanism. But what if Oumuamua is running into dense patches of dark matter scattered around the galaxy? This intriguing possibility, suggested by researchers like Lisa Randall from Harvard, proposes that dark matter could nudge off its expected path in ways that conventional gravity calculations can't predict. Understanding these interactions is crucial for determining the future trajectory of this deep space wanderer. As it continues its journey, these potential encounters with dark matter could subtly alter its course, offering insights into both its path and the mysterious nature of dark matter itself. Next, consider cryovolcanism, the fascinating icy counterpart to the fiery volcanoes we're familiar with. Instead of lava, cryovolcanoes erupt with substances like water, ammonia, or methane, which remain frozen in the frigid depths of space. This phenomenon has been observed on Neptune's moon Triton and the dwarf planet Ceres, thanks to missions like Voyager 2 and Dawn. If this space enigma carried such icy volatiles during its journey through interstellar space, they could have sublimated into gas as it neared the sun. This sublimation could provide the necessary thrust to alter its path, akin to how outgassing affects comets. However, the materials might be so unique that they left no visible trail, making it harder to detect but still influencing its trajectory. All these theories might give us a clue about where Oumuamua could be heading, but you might be wondering where it is right now. Did it stick around in our solar system, or has it zoomed out? Well, as of the last check-ins with our telescopes, tracking this interstellar object has turned into a real game of cosmic hide-and-seek. By early 2018, this speedy space cucumber had already whipped past Mars's orbit and was racing toward the outer edges of our solar system. We think it zoomed past Saturn's orbit in 2019, moving at a breakneck speed of about 26 kilometers per second. That's faster than anything you've ever ridden at an amusement park. Catching glimpses of this space rock has become super tricky for astronomers because it's getting dimmer and speedier. As it dashes away from both Earth and the sun, it's losing the sunlight that makes it visible to us, kind of like how a flashlight beam gets lost in a foggy night. The last peeks we got through our space spyglasses, like the Hubble Space Telescope, were back in January 2019. After that, it became too faint to spot with the tools we have now. Well, based on all the brainy math that astronomers do, this interstellar object is expected to leave our solar system for good and sail towards the constellation Pegasus. It's set to cruise through the stars, possibly bumping into other star systems or just wandering through the vast empty spaces in between for who knows how many millions of years. The big chase to understand and track this alien object has been like a pilot episode for what's coming next. With new space gadgets like the Virasi-Rubin Observatory gearing up to start in the early 2020s, we're getting ready to meet more of these interstellar wanderers. These future telescopes will help us keep tabs on them from farther away, and maybe tell us more about where they come from and what's out there in the big wild cosmos. Now the question arises, what stars or systems could be pit stops on its journey? Let's imagine this space enigma is on a cosmic road trip heading towards the northern sky and the constellation Pegasus. Well, it's pretty exciting to think about, especially since Pegasus is home to 12 star systems that have planets of their own. And guess what? One of these stars, 51 Pegasi, was the first sun-like star found to have a planet hanging around it, which kind of makes it a celebrity in the star world. Now, linking this to those wild, strange theories about the space wanderer, could there be a connection? Maybe it is zipping through to check out these planetary systems. It's like it has a list of cool places it wants to visit, with 51 Pegasi being one of the must-sees. Because of its historical status and our understanding of planets around other stars. But what happens when it finally reaches Pegasus? Well, even though it's fun to think about these pit stops, it's important to remember that space is massively, unbelievably huge. The distances between stars are so vast that this space interloper isn't likely to swing by any planets or stars close enough for a quick hello. Current projections suggest that after exiting our solar system, its path might bring it close to various other star systems, though such meetings would occur thousands or even millions of years in the future. The first step in understanding the future path of this cosmic probe involves mapping its trajectory relative to known celestial bodies. Based on data from its observed course through our solar system, and the hyperbolic trajectory, calculated by astronomers using observations from telescopes like Hubble and ground observatories, it is heading towards the constellation Pegasus. More specifically, the star Gliese 710, a K-type star much cooler than our Sun, lies along its path. Although direct interaction is unlikely, Gliese 710 and its associated solar system might come within 1.1 light-years of this space rock in about 1.3 million years, according to models predicting star movements and its trajectory. The gravitational influence of large celestial bodies Oumuamua might pass near is an intriguing aspect of its journey. If this interstellar object passes close enough to a massive object, such as a star or large planet, its path could be significantly altered by gravitational forces. This gravitational slingshot effect could change its speed and direction, potentially directing this interstellar object towards entirely different destinations. Speculating on these encounters, it's possible that close approaches to other star systems could not only alter its course, but also affect its structural integrity. If this alien artifact passed extremely close to a large planet or star, tidal forces could potentially fragment the object, much like what is believed to have happened to comet Shoemaker-Levy 9 before its spectacular collision with Jupiter. Its current velocity of about 26 kilometers per second will likely propel it through the Milky Way for millions of years, passing through the sparse regions of interstellar space, where stars are separated by vast distances typically measured in light years. But how can we be so sure about where this space enigma is going, and is it truly heading for Pegasus? Well, claiming where it's off to involves some pretty smart science. Researchers use advanced models that mix the laws of celestial mechanics with the details we've noticed in Oumuamua's path. Researchers use advanced models that mix the laws of celestial mechanics with the details we've noticed in its path. This system crunches numbers to figure out where celestial bodies are in our solar system and can guess the route of interstellar travelers. But predicting its road trip across the stars isn't simple. There are loads of uncertainties because of things we might not fully know yet. For example, the interstellar medium, that's all the cosmic dust and gases floating around in space, could nudge this space rock slightly off course over thousands of years. Plus, if it bumps into or even near other space objects, which have their own unpredictable paths, figuring out its exact route gets even trickier. Looking ahead, future tech looks promising for keeping an eye on such objects. The Vera C. Rubin Observatory, which is set to start doing its thing around 2023, will scan the whole sky over and over. It'll collect heaps of data on things that move through space, helping us get a better handle on where this type of interstellar object is going. And its fellow space wanderers are headed by giving us more detailed ongoing observations. As this space traveler continues its silent journey across the cosmos, perhaps one day it will find its place among the stars, a quiet home in the vast universe. But what about you? Are you still journeying through your own life, searching for your destination, or have you found your spot to shine? Hit the comments with your hand thingies.